Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring direct, inverse, and joint variation. Before we do, let's look at the equation of each type of variation and some common phrases that will help you know which equation to use. So let's start with direct variation. This is an equation you should feel familiar with, but it's y is equal to k times x. You'll know you're dealing with a direct variation equation when you see phrases like something is directly proportional to, or you might see something like varies directly with. If you see those two phrases, you know you're going to use the equation y equals kx. For inverse variation, our equation is y equals k over x. Some common phrases might be is indirectly, or sometimes you'll see inversely proportional to, or you might see something like varies indirectly or inversely with. If you see either of those phrases, you'll know to use the equation y equals k over x. Now, joint variation, our general formula is y equals k times x times z. And you'll usually see the phrase something like varies jointly with. Excuse me. So in example 1, it says use a variation equation to answer each of the following. So in problem A, it says the quantity y is directly proportional with the cube of x. If y equals 25 when x is 2, find y when x is 6. So what I want to do is highlight which direct variation equation we're going to use here. So here we have y is directly proportional with the cube of x. So that's the information we're going to use to write our equation. So they mentioned the variable y first, so we'll put y equals. Then they said it's directly proportional to, so we'll need a k times something. Now in this case, it's directly proportional to the cube of x. So that would be x cubed. So there's our general equation. Then it says if y is 25 when x is 2, find y if x equals 6. So they're telling us that the value of y is 25 and the value of x is 2. So 25 would equal 2 cubed is 8, and 8 times k is 8k. So now we know the value of k to be 25/8. Now, once you know the value of a, now you're just going to rewrite your formula now that you know the value of k. Okay, so y equals not kx cubed, but 25/8x cubed. Now, once you have your direct variation equation with the value of k, now it's time to answer the question, and I'm going to highlight that in a different color. The question asks us to find y when x is 6. Find the value of y when x is 6. So you'll simply plug in a 6 for the value of x. So instead of x cubed, I'll have 6 cubed. Now, I can complete this problem on my calculator. I've got 25/8. And I want to multiply that by 6 to the, 6 to the third power. So y would equal 675. So we took the given information. We used that given information to find the value of k. Then we used the value of k to write a new equation, and with that new equation we could answer the question. Okay. All right, let's look at another problem. In problem B, it says the quantity y varies inversely with the cube of x. If y is 25 when x equals 6, find y when x equals 3. So let me highlight our given information that we need to write the equation. So y varies inversely with the cube of x. So I want to go back up here to my chart and look up the formula for inverse variation, which is y equals k over x. So this would be y equals k over, and what does y vary inversely with? It varies inversely with the cube of x, so x cubed. So there's our general formula. Now, our given information here is that if y equals 25, when x is 6. So I'm going to put a 25 for the y and a 6 for the x. Now, to solve for k, I'm going to have to multiply both sides by 6 cubed. So this would cancel with this, leaving me k on this side. And over here, 6 cubed times 25 gives me 5,400. Now that I know the value of k, I'm going to use it to write a new formula. So instead of y equals k over x cubed, I'm going to write y equals 5,400 over x cubed. And that's the formula I'm going to use to answer the final question. Let me highlight the final question. It said find y when x equals 3. Find the value of y when x equals 3. So y equals 5,400 over 3 cubed. So I can put that in my calculator, 5,400 over 3 cubed, which would be a value of 200. Problem C. In a geometry problem, a quantity v varies jointly with h and the square of r. So let me highlight that. V varies jointly with h and the square of r. So let's go up to joint variation. We have y equals k times x times z. So this will be v equals k times h times the square of r, which would be r squared. Okay? Now let me highlight the given information here. It says v equals 45 pi when r is 3 and h is 5. So let's plug in that information. We have 45 pi equals k times 5 times 3 squared. So if I simplify that, 45 pi would equal 3 squared is 9. 9 times 5 is 45. So this would be 45k. Now divide both sides by 45. Divide both sides by 45. And you'll get pi is equal to k. So now that I know what k is, I can come over here and rewrite this formula. So instead of writing v equals k times h times r squared, I'm going to write v equals pi times h times r squared. And now I can use that formula to answer the final question. So let me get my highlighter here. So the final question we want to know is find r when v equals 175 pi and h equals 7. So I'll put a 175 pi for the volume, and then pi times 7 times r squared. So 175 pi equals 7 pi r squared. So I'm going to divide both sides by 7 pi. The pi's will cancel out, and 175 divided by 7 is 25 equals r squared. Now take the square root of both sides. So r would equal 5. Now, normally we would use plus or minus here, but because it told us it was a geometry problem, we know that r, or the radius, cannot be negative. So I'm just going to use the positive value of r, which is 5. All right, in example 2, let's look at some word problems. Solve each of the following. In problem A, it says when an object is dropped, the distance that an object falls varies directly with the square of the time of the fall. If an object falls 144 feet in 3 seconds, how long will it take for the object to fall 1,024 feet? So I want to highlight here how to know which of the formulas to use. So let me go back. It said the distance the object falls varies directly with the square of the time. So it's the distance varies directly. So by varies directly, we would use this formula. Okay, so in this problem, though, we don't want to use y and x because we won't know where to plug in our numbers. I want to use letters or variables that represent what's going on in the situation. For distance, I'm going to use d equals k times something. So what does it vary directly with? It varies directly with the square of the time. So I'm going to put t squared. So there's our basic equation. D equals k times t squared. Now use your given information to find k. We know the distance it falls is 144 feet in 3 seconds. So I'll put a 144 for the distance, and I'll put a 3 for the time. So 3 squared is 9, so 144 equals 9k. Divide both sides by 9. 144 divided by 9, that gives me 16 is equal to k. Now, once you know k, you're going to go back and plug in that value of k to your original equation. So instead of d equals k times t squared, I'm going to put d equals 16 times t squared. Now, we're going to use that formula to answer the question, which was, let me grab a different color that I haven't used yet. How about yellow? How long will it take for the object to fall 1,024 feet? So I know the distance is 1,024 equals 16. We do not know the time. Okay, so I'll divide both sides by 16. So 1,024 divide by 16 gives me 64 equals t squared. Now take your square root, both sides, and we're only going to use the positive answer here because we're talking about number of seconds. So it will take 8 seconds to fall 1,024 feet. Problem B. The weight of an object above the surface of the earth varies inversely. So I'm going to stop right there and put the formula for inverse variation with the square of the distance from the center of the earth. If an object weighs 50 pounds when it is 3,960 miles from Earth's center, what would it weigh if it were 10,000 miles from Earth's center? All right, so let's highlight our given. The weight varies inversely with the square of the distance. So W equals k over distance squared. All right, so our given information, the object weighs 50 pounds when the distance is 3960. So 50 pounds is the weight and 3960 is the distance. So to get k, I'm going to multiply 50 times 3960 squared, and that will be 784,080,000. So 1, 2, 3. So 784,080,000. Now we'll use that. So weight equals 784, 080 divided by d squared. Now we can answer the question, what would it weigh if it were 10,000 miles from the Earth's center? So the weight would equal 784, 080, 1000 divided by 10,000 squared. So we'll use our calculator here, 784, 080, divided by 10,000 squared. And we get approximately a weight of approximately 7.84 pounds. All right, problem C. The area of a trapezoid varies jointly as its height and the sum of its bases. So let me stop right there. Area equals K times the height times the sum of the bases. And a trapezoid has two bases. So that would be base 1 plus base 2. Okay. If the area is 480 square meters, so I'll plug that in, and the height is 20, and the bases are 28 plus 20, then we're going to find the value of K. So this would be what? 48 times 20. 48 times 20. So 960K. Now if I divide both sides by 960, I would get 0.5 is equal to K. So now my formula is going to be area equals 1/2 times the height times base 1 plus base 2. And we can use that formula to answer the question. What is the height of a trapezoid when its area is 100 square meters and its bases are 10 and 15 meters? So half, we do not know h, but we know this is 10 plus 15. So 100 equals 1/2 times h times 25. So I'm going to multiply, or excuse me, yeah, let's get rid of the 1/2 first. So I'll multiply both sides by 2. So that would be 200 equals 25h, and then divide. So 200 divided by 25 would give me a height of 8. So our height is 8 meters. And that concludes today's lesson, direct, inverse, and joint variation.